All right, boys. 9-4, Pythagorean Theorem. Some mathematicians call this the most elegant theorem of geometry. They call this because there's a lot of uses for it. You can find distances of sides of a right triangle. You can also determine or classify the type of triangle that you have based on its angle. And it comes from a very simple formula. C squared equals A squared plus B squared. A and B are the legs of the right triangle. It does not matter which leg you call A or which leg you call B. Here I have this as leg A. Okay, great. Here I have this as leg B. Okay, great. I could just switch it around and go leg B and leg A. Doesn't really matter. Okay? The legs are the legs. The legs are going to be basically the altitude and the base of the right triangle. Now, across from the right triangle, from the right angle rather, is the hypotenuse. Okay? The hypotenuse is C, and that will not change. That is not interchangeable. The hypotenuse is always the hypotenuse. It is always the largest side of any right triangle, always. And it is always directly across from the right angle. So it's always the largest side, and it's always across the right angle. Very simple, okay? Now, the formula C squared equals A squared plus B squared is very useful. First of all, if C squared equals A squared plus B squared, you're going to have a right triangle. Very easy. Now, what happens if C squared is less than A squared plus B squared? Someone said the answer, very good. It's an acute triangle. Very good, son. Very good. And an acute triangle, again, means that the triangle has angles that are all less than 90. And then, what do y'all think it would be if C squared is greater than A squared plus B squared? It's going to be obtuse. Oh, I messed up on that one. Sorry about that. Oh, no, it should have been. Should have happened. Oh, well. Bye-bye. Bye-bye. Obtuse triangle. So that means that you're going to have a triangle with one of the angles larger than 90 degrees. So this is very awesome. It's very good. The formula works. You're going to use the formula and solve everything you want and need. However, yes, sir. It's funny how you just said that the question was, are they going to give it to us in the SAT? The SAT is riddled with this. All sorts of this stuff. However, the SAT on purpose is going to give you this so that you can use the formula. But I'm going to take you ahead. In 9.6, you're going to learn about the Pythagorean triples. Well, I'm going to teach that to you right now. It says there in red, memorize the Pythagorean triples. The Pythagorean triples are right triangles that have already been formed. They've been tested, okay? They've been tested, tried, and true forever. If you can recognize the sides of these Pythagorean triples, you're going to save yourself an enormous amount of time. So let's check out these Pythagorean triples. Okay? Now, not bad, huh? All right. So the Pythagorean triples, I'm not going to bore you with the formula again. It talks about the Pythagorean theorem. Shows you an example, bless you, of a Pythagorean theorem again. Shows you in block form, but you guys are beyond that. Let's get right to what I want to show you. In this particular case, see how here it says infinitely many more? You will never, ever, ever memorize every single Pythagorean triple. It's just stupid to think that you will. Okay? I mean, there are an infinite amount. Come again, son? They request to zoom in. Sure. Of course. Wait, I'm going to have to close the ink layer here first. Come on, come on. I don't want to restore. Okay. Let's go 200. Now, let's go 150. Is that better, son? Okay. Thank you, my man. Now, there's an infinite number of these. However, there are some very popular ones that are going to be seen on the SAT, in your geometry book, on your quizzes, on tests, and in other math classes in the future. The 3, 4, 5 triangle, the 5, 12, 13, the 7, 24, 25, the 8, 15, 17, and the 9, 40, 41. Now, you think, okay, there's only 5 to learn, that's no big deal, but it only gives us 5, Mr. Morrow. No, it actually gives you already an infinite amount. Because not only are these Pythagorean triples, but multiples of those are also Pythagorean triples. So if I gave you a triangle with a side of 9 and 12, you better believe that this is going to be a 15. What? Why? How? That's not one of those, Mr. Morrow. Yes, it is. It's the multiple of that. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. It's the power of knowing the triples. Now, you want to go home and not even look at this? That's fine. You're going to still be able to do it. You're going to use the formula. You're going to have no problems, except you probably won't finish the test on time. And I'm not going to worry about it, okay? So please do yourself a favor. Not me. I already took my SAT. I already passed this class. I'm giving you a really big heads up. If you memorize these triples, I promise you, not only will your homework go quicker, your quizzes and tests will go quicker, but really important, the SAT will be a lot easier and more manageable. Okay? Does that make sense, gentlemen?
Yes, sir.
Hey, let's go ahead and apply some of this then. Okay? Let's go ahead. Sorry about that. I should have erased that before. Okay. Here. Solve for x. It's 6, 8, 10. This is a 3, 4, 5. It's 10. Done. Now, what if you didn't recognize that? You are a human being. Sometimes you just may not recognize it. No worries. Very good. X squared equals 6 squared plus 8 squared. So x squared is 36 plus 64. So x squared equals 100. So x equals plus or minus 10, but you're only using the positive because you cannot have a side of a polygon that is negative. Does that make sense, gentlemen?
Yep.
All right. Give me 1 second here. All right, boys. Thank you very much for your patience there. All right, so number 2. Let's find the perimeter of the rectangle shown. All right. Well, all right, all of you are already jumping on there. That's a great job, guys. X is going to be 12 because this is a 5, 12, 13 triangle. Now, some of you may say, whoa, hold on. How on earth did you know that this is a right angle? It's a rectangle. And I know the definition of a rectangle, so I'm all good. Now, again, if you didn't know this in particular, no worries. 13 squared equals x squared plus 25. That's 169 equals x squared plus 25. 144 equals x squared. X equals 12. Does that make sense, my brothers? All right. Let's continue, please. Now, find the perimeter of the rhombus with diagonals of 6 and 10. Okay, wrong. It's not 4. Thank you for that mistake, though. Everyone that said it was 4, good thinking, but you're not thinking. Let's, hold on, relax. This is a rhombus. What do we know about the diagonals of a rhombus? They are perpendicular bisectors. So if that's the 90, could that be 4? Not even remotely possible. The side opposite the 90 is the hypotenuse. The hypotenuse is always the largest side. So that cannot be 4. Cannot. But I can do x squared equals 9 plus 25. So x squared equals 34. So x equals the square root of 34. So if x equals the square root of 34, what would my perimeter be?
A plus square 4 radical 34.
Guys, aren't there 4 equal sides in a rhombus? So whoever said 81, no. This is 4 times the square root of 34, not 81 for all of you out there in the computer land. Not 81. Are you kidding me? No, this is not 4 square root of 4 units squared. It is units. Because it's a perimeter, my brother. Area would not be that. Area, correct, would be 34 units squared. Yes, sir, my brother. Because square root of A times square root of A equals A. All right? Thank you, sir. Now, Nadia skipped 3 meters north, 2 meters east, 4 meters north, 13 meters east, 1 meter north. How far is Nadia from where she started? Well, who cares? No, I'm just kidding. I'm just kidding. We all care about Nadia, okay? Now, Nadia is over here, right? And she, very good. So we're going to start her right here. So she went up 3 meters, because that's north. Then she went east 2 meters. If you don't know what east is, remember this, guys. Never eat soggy wheat, or never eat soggy waffles, whatever. Now, so she went 3 meters north, 2 meters east, 4 meters north, 13 meters east, and then 1 meter north. Now, I want to find the distance. Now, I know that some of you may be tempted to say, well, just add 3 plus 2 plus 4 plus 13 plus 1. That will not be the distance from that point to that. What do you think we have to do here? Auxiliary line? Yes. When I draw an auxiliary line from here to here, yes. Then I come up and I create a right triangle. Okay? What is the distance from the starting point to the maximum height here? 3, 7, 8. What is the distance from here to my ending point? 15. Okay? This is 2 plus 13 is 15. Do I have a Pythagorean triple for an 8, 15? It's 8, 15, 17. So 17 meters is her distance. No, we can't just put who cares. That was just some humor. And it worked because everybody laughed. All right? But if you didn't know this triple, no big deal. You've got x squared equals 64 plus 225. X squared equals 289. X equals 17 on the money. Because the square root of 289 is 17. Does that make sense, gentlemen? Okay? Almost done. Find the altitude of an isosceles trapezoid whose side lengths have side lengths of 10, 30, 20, 10. First things first. What do we know about isosceles triangles? Okay, the legs are congruent. Bam. The bases and the upper bases. Very good job. Very well done. Nice. And this is parallel to that. Fantastic. So with the information they gave us, what are these sides here? So that's 10 and 10 because those are the equal sides. 20 and 30. Okay? You with me so far? Now, I'm gonna make some magic happen here. Check it out. I need to find the altitude, which is this right here, correct? But let's think about this. If I go from here to here, okay? Let's look at these two triangles that I'm going to outline in green for a second. Okay? In this particular case, isn't this a 90 because it's an altitude? Isn't this a 90 because it's an altitude? So isn't this triangle here on the left congruent to this triangle here on the right because of angle, angle, side? Angle, angle, side? So doesn't that mean that this little segment has to be equal to this little segment? Well, then let's think about this. If from here to here is 20, and down here is 30, don't I have 10 left over? But don't I have to split that in half? So 5 and 5. Now there is not a special Pythagorean triple for this, so this is easy. 100 equals 25 plus x squared. 75 equals x squared. X equals 3 square root of, wrong, I was trying to show off. And it's 5 radical 3, sorry, because it's 25 times 3, the square root of 25 is 5. So my altitude is 5 radical 3. Does that make sense? I got 5 minutes left, right? Perfect. We're good with this, gentlemen, so far? All right. Last but not least, classify this triangle. We don't know what kind of a triangle this is, okay? But, all right. So this is going to be, we'll find out right now. How do we set this up, first of all? What would be my C here? Not the 7. The C would be the largest side. So 8 squared must equal 7 squared plus 5 squared if that's going to be a right triangle. This is 64 equals 49 plus 25. So 64, unfortunately, does not equal 74. In fact, 64 is less than 74. So absolutely, this is an acute triangle. Does that make sense, everybody? Yes, sir. Hold on, guys. I got a question here. If a triangle,
sides of a triangle aren't multiples of the Pythagorean triples, does that mean that it's not a right triangle?
no, the question was if the sides are not multiples of Pythagorean triples, does that mean it's not a right triangle? Absolutely not. No, absolutely not. You got to actually test it out. It's not always going to be a Pythagorean triple. There's a lot of right triangles out there that are not Pythagorean triples. Okay?
Pardon the interruption. Is Nicholas Hernandez in class?
Yes.